Hi all, I am here with my new video on chapter 10, Reduction, Oxidation and Electrochemistry. Let's start. In this video we will learn about electrochemical cells. An electrochemical cell is a device that relates electricity to oxidation reduction reactions. There are two types of electrochemical cells, voltaic cells, electrolytic cells. In this video we will learn all about voltaic cells. Voltaic cells or galvanic cells use a spontaneous redox reaction to provide a source of electrical energy. It is designed so that the oxidation and reduction half reaction occurs in separate half cells that are connected to one another. Under standard laboratory conditions, electrochemical cells are constructed to operate at 298 K and 100 kilopascals. All solutions have a 1 m concentration. Any gases present have a partial pressure of 100 kilopascals. On this slide, a simple design for a voltaic cell is shown. Reactions in a voltaic cell. Oxidation occurs in the left half cells and reduction occurs in the right half cell. The electrons that are released travel through the external wire and enter the copper metal. The metal stripes are called electrodes. The electrode at which oxidation occurs is the anode and the electrode at which reduction occurs is the cathode. As the reaction progresses, an electrical imbalance will stop the voltaic cell from functioning. However, the porous barrier allows the migration of positive and negative ions between the half cells, keeping them electrical neutral. In the diagram, the flow of negative and positive ions are shown. If we connect the external wire to an external circuit, we will have usable source of electrical energy, and that is the concept of a battery. The anode of a voltaic cell is negative terminal because electrons are flowing out of it. The cathode of a voltaic cell is a positive terminal because electrons are flowing into it. After a period of time, the redox reaction reaches at equilibrium and the cell no longer operates. When this occurs in a battery, it is called dead. On this slide, we can see voltaic cells with salt bridge diagram. Operation of voltaic cells with salt bridge. These cells are type of voltaic cells in which half cells are separated. Here we have salt bridge to allow for the flow of ions between the cells. As shown in the diagram on previous slide, the salt bridge contains an electrolyte such as KCl, potassium chloride, that is dispersed throughout a gel such as agar. The gel provides firmness but allows ions to flow through it. Since zinc 2 plus aqueous is produced in the left half cell, ions are required to keep the solution electrically neutral. Therefore, chlorine ions flow into this half cell. At the same time, Cu2 plus is being used up in the right half cell, which requires positive ions to keep the solution electrically neutral. Therefore, potassium ions flow into this half cell. In our next video, we will learn about electrolytic cells. To watch new videos, please subscribe and like our videos.